Hey everyone! In this video, I would like to talk about the effective annual yield formula. So remember, the effective annual yield would be the simple interest that would produce the same amount of money as an investment that is subject to interest compounded monthly. So it gives us a great way to compare investments. So what I'd like to do is develop the formula for effective annual yield, and then I want to talk about how to use that in a couple examples. So remember, the way that we found effective annual yield is we found the future value of an investment compounded a certain number of times a year. So the formula for compound interest, principal times 1 plus r over n to the nt power. And then what we did is, after we found that future value, we compared that to the simple interest formula. So the simple interest formula is the future value is equal to the principal times 1 plus r times t. So now I want to combine these together and just talk about how we get our effective annual yield formula. So what we did is, after we found this future value, after it's compounded, we set that equal to our simple interest formula. So what that's going to end up looking like is we have our principal times 1 plus r over n to the nt. Now remember, this entire thing would give me a future value, and now we set that equal to our simple interest formula so that we could solve for r, the rate, which is going to give us our effective annual yield. So now we can make this a little bit easier to work with. The first thing is, if I divide by p on both sides, there's a p in the numerator and denominator, so both of those are going to simplify. And we get 1 plus r over n to the nt. And on the other side, we're left with 1 plus r times t. Now the other thing that we can take into account and change here is that whenever we're looking at effective annual yield, we're only looking at 1 year. So for t, we'll just plug in 1. So those t's can go away. And we have 1 plus r over n to the n power. And that's equal to 1 plus r. And remember, we want to solve for r. R is going to be our effective annual yield. So subtracting 1 from both sides, we get our annual yield is equal to 1 plus r over n to the n power minus 1. So here's a formula that will help us find the effective annual yield. A couple things to notice here. Since we got rid of t for time, we don't need to know the time for an investment. All we need to know is the rate and the number of times it's compounded, and we can turn that into an effective annual yield. So now that we have that established, let's use this in a couple examples. So the first one says, a passbook savings account has a nominal rate of 5%. The interest is compounded daily. Find the account's effective annual yield. So again, just to rewrite our formula, our yield is going to be equal to 1 plus r over n to the n power, and then minus 1. So let's plug in what we know and find our effective annual yield. So we have 1 plus our rate, which is 5%. So I'll write that as a decimal, 0.05. And then our interest is compounded daily. So n is going to be 365. Okay, after plugging everything in, we can go to our calculator, type this in. Again, just remember, we need to work our way from the inside out. So starting inside our parentheses, we'll start with 0.05 divided by 365. Right now that looks like a goofy decimal because it's written in scientific notation, which is totally fine. But to that we'll add 1. Adding 1, now it looks a little bit more normal. This decimal is going to be raised to the 365th power. So we get 1.051. And then from that, we're going to subtract 1 as the very last step. So this is our effective annual yield as a decimal. So 0.0512. So about 0.0512. And then to get our effective annual yield, let's rewrite this as a percent So we end up with about 5.12%. So our effective annual yield is about 5.12%. And again, what that means is our normal interest rate compounded daily was 5%, but a simple interest rate of 5.12% will give us the same results. It will give us the same future value, even though it's simple interest now. Let's take a look at one more example. This one says, which is the better investment? 5% compounded monthly or 5.25% compounded quarterly? So as I said in the beginning, effective annual yield is a great way to compare investments. So I don't need to know how long the money is going to be in either of these accounts. I don't need to calculate the future value for either of these. I can just compare the effective annual yields. So let's see what we end up with. So just to rewrite our formula, 1 plus r over n raised to the n power minus 1, and we're going to do that for both of these. So I'm going to just write this down twice. So for our first investment, we have a 5% interest rate, and it is compounded monthly. So 1 plus 5% as a decimal, 0.05, and compounded monthly, so that means n is going to be 12. In our second investment, we have 5.25%, and that is compounded quarterly. So as a decimal, 0.0525, and then compounded quarterly, that's 4 times a year, so n is going to be 4. Okay, so we plugged in everything we know. So now let's type this into the calculator and see what we get for both of these. So for our first one, working our way from the inside out, 0.05 divided by 12. To this, we're going to add 1. Okay, I'm following my order of operations. So this decimal would be what is inside the parentheses. And this is going to be raised to the 12th power. So 1.0511. And then from this, we're going to subtract 1 to give us our rate as a decimal. So 0.0512 about, if I round. So 0.0512. So then writing this as a percent, multiplying by 100, we get about 5.12%. Now let's do the same thing for our second one. So typing this in, we'll start inside our parentheses, so 0.0525. That gets divided by 4. To that, we're going to add 1. So that's the decimal that would be inside the parentheses. That gets raised to the 4th power. And then we are going to subtract 1. So here's our effective annual yield as a decimal, 0.0535. So this is about 0.0535. So our effective annual yield as a percent multiplied by 100, we end up with about 5.35%. So these two effective annual yields, remember these would be the simple interest rates that would give us the same future value. So the better investment is going to be the one that has the better simple interest rate. So that means that our second investment, the one with the 5.25% interest compounded quarterly, is actually the better investment. And this does bring up a good point. A lot of times the better interest rate is the better investment. So even though this first investment is compounded more often, because the second one has a higher interest rate, we do end up with a better simple interest rate, a better effective annual yield, which means it's a better investment.